All right, I think this is where we left off yesterday. Yes, I'm not crazy. Yeah, okay. This is, I think, 3B. I don't remember. Johnny has 2 containers. Again, we're going to finish this page. Then we'll do 6 examples together. And then you'll have 5 left. Don't do those today. We're going to do them tomorrow. So just hang tight on those. Johnny has 2 containers. One has 50 milliliters of orange juice concentrate. The other has 80 milliliters of orange juice concentrate. Orange juice concentrate is pure orange juice. He mixes the 2 containers together and creates a mixture that is 30% orange juice. How much pure orange juice or orange juice concentrate is in his final mixture? How could we find this? How much of the final mixture is orange juice concentrate? 30%. How do I write 30% as a decimal? 0.30. Okay. And that's of his final mixture. How much is in his final mixture? 50 and 80, right? So 50 plus 80. So multiply that by 50 plus 80, and we'll get how much orange juice is in his final mixture. Somebody do that in your calculator, and let me know what you get when you get it. 39. Awesome. 39 what? Milliliters. Good. Awesome. Part C, we're making a new chemical by mixing 2 vats together. A vat is just a large container. When we mix the 2 vats together, we have 1,000 gallons. Write an equation to represent the total mixture amount. All right. What do we not know? The amount in vat 1. So X equals, the amount would be in milliliters. So let's say milliliter amount is AMT in vat 1. What's Y going to be? Amount in vat 2. So milliliter. Oh, I'm not doing milliliters. What am I doing? Gallons. Yep, I forgot we're doing vats. Those are big. Gallon amount in vat 2. Sorry about that. So the amount of mixture in vat 1 is X. The amount of mixture in vat 2 is Y. What are we going to do with those 2 to find the total amount? Add them together. So we're adding these together. What is that total amount? 1,000. So that's your total amount equation. Now we know that vat 1 contains 6% HCl and vat 2 contains 10% HCl. Our total mixture contains 8% HCl, and we want to write an equation to represent the amount of HCl in our final mixture. So if I want the amount of HCl in vat 1, what would I do to X to find that? X is the amount in vat 1. How much of vat 1 is HCl? 6%. What's 6% as a decimal? 0.06. So I could go 0.06 times X, and then tell me how to find the amount of HCl in vat 2. Close. Vat 2 is 0.10 times Y. My total amount is how much? 1,000, but how much of that is HCl? 8%. So this is really 1,000 times 8%, yes? Or 0.08. That should be 0.08. What am I going to do with 0.06x and 0.1y to get 1,000 times 8%? Add them. So you have one equation, x plus y equals 1,000, to represent the amount in each vat and the total amount. And then you have a separate equation for the concentration in each vat and the concentration overall. Make sense? Flip it when you're ready. We're going to do 6 of these. We'll jump around a little bit. And then tomorrow we'll do the other 5. There is a 5-step plan in solving word problems here. I would star this and come back to it if you have problems in your homework that you're unsure of how to do. Your homework will involve word problems before Friday because you have a test on Friday and that test will have word problems on it. Number 1, you're going to define your variables just like we just did. You're going to write your equations. Then you're going to work the problem in one of 4 ways. Tell me the first way we learn to solve systems. 2 equations. Before that, graphing. So first way is graphing. And then it was elimination. And then it was substitution. That was all unit 0. And then unit 1 is all about matrices. We're going to practice in these notes solving by matrices because that's the new part. You do need to know how to solve these equations by graphing, elimination, or substitution if I asked you to, but that is unit 0 stuff. We're going to focus on matrices today. Make sure your answer makes sense when you're done, and then write your answer as a conclusion statement. Make sure to write your conclusion statement because that will earn you points. Number 1, a father, are we ready to move on? Scream if you're not. Number 1, a father is 4 times as old as his daughter. In 12 years, he will be 2 times as old as she is. How old is the daughter now? What is X? What do we not know? Father's age, okay. Father's age. What else do we not know? Daughter's age. So let's make that Y. So Y is daughter's age. Okay. How do I write an equation for a father is 4 times as old as his daughter? X equals 4Y. Good. So you're taking the father's age, and that is equal to 4 times the daughter's age. If it says in 12 years, what do we need to do to both of their ages? Add 12. So keep that in mind. We got to add 12. He will be 2 times as old as she is. So to his age, we're going to add 12. So we're going to say X plus 12, and that's equal to, if it's 2 times as old as she is, it's going to be 2 times what her age will be in 12 years. So we have to do Y plus 12, and your 2 should be multiplying Y plus 12 because it's going to be 2 times as old in 12 years, if that makes sense. We're going to solve this by doing this part. Writing it as an augmented matrix and solving using our calculator. I'm not necessarily going to put the work down there. If I want to write an augmented matrix, what do I have to make sure of first before I even start writing my matrix? Standard form. How do I get the first equation in standard form? Yep, move the 4y, right? How do I move 4y? Subtract 4y. So x minus 4y, what is that going to be equal to? 0. I moved everything on that side, so there's 0. Okay, now the other one. We got to actually distribute here. So I'll have x plus 12 is equal to 2y plus 24. Tell me what needs to move. The 2y, we got to subtract the 2y. What else? 12. We got to subtract the 12. So I'm going to end up with x minus 2y is equal to 12. Those are the 2 equations I want to use to write my matrix. You have to do that work up front, then you can use matrices to solve. Yes? Let's write this as an augmented matrix. So I'm going to draw an arrow. Augmented matrix. In front of my first x is a 1. In front of my first y is a -4. ... My first equation is equal to 0. My second equation in front of x is 1. In front of y is -2. ... It's equal to 12. Y'all remember in note set 3 how we were doing all those row operations to get down to a matrix that was like 1, 0, 0, 1? Y'all remember that? So what we were doing when we were doing row operations is getting down to, don't know if you remember this vocab word, but reduced row echelon form. Yes? That's what we're going to do in our calculator. So what we're showing up here on your notes is the bare minimum amount of work that you need to show on your paper for homework, tests, and quizzes to get credit. Yes. Sure, if you need to. We're going to find the reduced row echelon form of this matrix. So you need to write RREF in front of that matrix because that's what you're doing with that matrix to get your answer. Now we have to put equals, and you're going to actually write down the matrix that your calculator gives you. Questions so far? Calculator time. Find matrix. Where's it at? It's blue above the x to the -1. That's actually your inverse button. I know we haven't gotten there yet, but you'll know what that means later. This is where, next to sign, you used sign a lot in geometry last year. Yeah. So it's in blue. So what do I have to press before I do that? Second, and then matrix. Now, the first menu is just naming your matrix. If you want to identify your matrix, you need this menu. We'll need it later. We want to actually make a matrix. So go over to edit. We'll just edit matrix A because, you know, that's the first one. What are my dimensions? 2 by 3. That's why it's important for you to know. 2, enter. 3, enter. Now you can type your entries in. Type enter after every single one of them, including the last one. So, yeah, there we go. We got 1, enter. -4, enter. 0, enter. 1, enter. -2, enter. 12, still press enter, even though it's the last one. It won't go into that cell or into that element unless you press enter after it. Does your matrix look like mine? Yes? You need to quit out of this. How do you quit? Second mode, the button right to the right of it. Second mode. Now we have to do math with our matrix. So let's go back to matrix. So second matrix. You want your calculator to do math with this matrix. So go over to math. And then what we want is the reduced row echelon form of this matrix. It is easier if you press up because it's one of your last options. I don't need comments about the cumulative sum. Don't need comments about that, okay? Option 0 is the cumulative sum. We don't need to talk about it. Option A is row echelon form. It's not reduced. Option A is not going to help you. You want option B. Okay, so row ref, not just ref. Ref. Okay, press B. Enter. Now you have to name which matrix you're actually wanting it to row ref. So we got to go back to matrix. Second matrix. This is where you just want to name it. So enter. You should have row ref of matrix A. When you press enter, it will give you the answer. I didn't type in something right. What did I not put? Ooh, the 1. Right here? There we go. How did I know I did something wrong? It is. What's on the end? Yeah, age can't be negative, so I knew I did something wrong. There it is. 24 and 6. What is 24? Oh, the dad's age, what is 6? The daughter's age, let's go 1, 0, 0, 1, ... 24, 6. So you have to show me your equations. You have to show me which matrix you're reffing. Then you have to show me what matrix you got out. Then you can write your conclusion statement. So conclusion statement, the father is 24. The daughter is 6. All right. I know this is a long day. I know. I'm sorry. Good news is we only have 5 examples to go. And then tomorrow, I'm not teaching you at all. So that's going to be good. Number 2, a bouquet of 2 roses. That's important. And 6 carnations. That's important. Cost $17. That's important. A bouquet of 6 roses and 12 carnations costs $42. The question is asking what is the cost of each type of flower. The question will usually tell you what your variables have to be. What's x going to be equal to? What about a rose? Cost of how many roses? 1 rose. So cost of 1 rose. What's y equal to? Cost of 1 carnation. All right. I think I want to call on people. Yeah, I think so. Hey, Lakin, you're lucky number 1. Will you tell me what the first equation is going to be? How many x's? Okay. Ooh. Ooh, close, close. The X represents roses, right? How many roses do you start with? A bouquet of... Oh, okay, you're doing the second one. 6 roses. And how many carnations? 12 carnations, so that's Y is equal to how much? 42. So that's the second one, which is fine. That's awesome. Great. Mateo, will you give me the first equation? Good. Good. So 2x plus 6y equals 17. There's our system. Ready to solve it? Yeah? Hey, Nix, will you read me the first row of our augmented matrix? 6, 12, dot, dot, 42. That's going to be the bottom row for me because that was the second sentence, but that's fine. It doesn't matter. And then let's see. Maggie, will you read me the top row of our augmented matrix? Perfect. Awesome. Hey, James, remind me, what are we going to do with this matrix to solve it? Okay, and do what? Like, what do I need to write down on my paper for Miss B if she were grading my paper? Somebody's saving you. What is it? RREF. And then our calculator can do it for us. We got to go equals and write what matrix is going to happen. Go ahead, row ref this, find the matrix that is your solution matrix. I will let you do that on your own matrix. What'd you get? Top row first. 1, 0, dot, dot, 4. And then what? 0, 1, dot, dot, 1.5. Did anybody get anything different? Awesome. All right. This is for anybody. Tell me your conclusion statement. We'll start with roses. Okay, 1 rose costs $4. I'm going to write roses are $4 each just because I started writing before you said anything. Sorry. And then tell me the second part of our statement. 1 carnation is $1.50. Awesome. What? No, we're not done. How many examples do we have left? Anybody remember? 4. 4 more examples. Oh, I'm going to change this. 1 rose is $4. Okay. We're going to skip number 3. We're going to do number 4. Hey, I promise number 4 is going to pay off for you. Trust me, it's going to pay off for you. A coin bank contains 27 coins. All nickels, dimes, and quarters. Ooh, interesting. The combined value of the nickels and the dimes is 90 cents. The combined value of the dimes and the quarters is $4. How many coins of each type are there in the bank? What's X going to be equal to? What do we not know? The number of nickels. So number of nickels. That's a great place to start. Number of nickels. What's Y going to be equal to? Number of dimes. Perfect. I promise this will pay off for you. Number of dimes. Hey, what's great about this one? There's a Z. Yeah, number of quarters. Awesome. All right, let's see. Trinity, can you make me an equation out of the first sentence using 27 coins? Perfect. Equals, ooh, I wanted the first sentence, so the 27. You're close on the second one, though. How do I get the 27? Perfect. All my nickels, X, plus all my dimes, Y, plus all my quarters, Z, is going to equal 27. Really close on that second equation, okay? But it says the combined value of the nickels and dimes. What's the value of a nickel? 5 what? 5 cents. So for every nickel, which is X, I'm going to want to multiply by 5 cents. So 5 cents for every nickel, 5 cents for every X, plus how much for each dime? 0.10 for 10 cents, and then dimes is Y. It says the combined value of the nickels and dimes is 90 cents, so that's going to be equal to 90 cents. Isabella, using that same idea, let's make the last equation for that sentence that has $4. What would that look like? Close. Dimes are how much? 10. So this will be 1.10y plus your quarters is 0.25z, and that's equal to 4. Good. All right, Cooper. Turn it into a matrix for me. Hey, first of all, what are the dimensions going to be of my matrix? How many equations do I have? 3. How many variables do I have? 3, and I also have a total, right? So my matrix is going to be 3 by X, Y, Z, total. 4. 3 by 4. All right, let's do this. 3 by 4. I'm going to write it over here. 3 by 4. Will you give me the first row in my matrix? Using that first equation, X plus Y plus Z equals 27. What's in front of X that you don't really see? A 1. So 1, 1, 1, 27. Yes? Matthew, give me the second equation, or the second row in our matrix. Good. 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 Notice that there's a 0 in the third column because there are no quarters in the second equation. There is no Z, so the coefficient in front of Z, if there isn't one, is a 0. And then using that same idea, Raven, will you give me the bottom row of our matrix using that bottom equation? Okay. Why did I leave the first spot open? These are my x's, right? How many x's do I have in the bottom equation? Do what? Yep, so that's going to be 0. Yep, and then y's, and then z's. There we go. We're back on track. Finish it for me. Yep. Yep. Perfect. All right, I already hear calculators. I hope if you're typing in your calculator, you put RREF on your paper. If you didn't, you need to put that on your paper. Then you can row ref. The only thing you need to change when you're putting in your matrix is you need to change the dimensions from 2 by 3 to 3 by 4. Then you can put all your numbers in. I'll let you do that, and then we'll figure out what our conclusion is. Right, I'm going to show this one really quickly. Changing my matrix to a 3 by 4. Tell me if I make a mistake. Ah, that's a mistake. And then this one was 0.05, 0.10, 0.10, 0, and 0.90. Yes? 0, 0.10, 0.25, and 4. The reason I'm doing this one is because if you quit out of this, if I just RREF'd A, you can go second and then enter, and it brings up what you just did, and you just have to press enter again. You don't have to go back to RREF and matrix A. How many nickels? 8. How many dimes? 5. How many quarters? 14. So this should have been 1 0 0 0 1 0 0 0 1 dot 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 8 5 14. Yes, you have to put that matrix down. And then 8 nickels, 5 dimes, 14 quarters. Y'all want to know how this is going to pay off for you? Did you write everything down? Yes? Hey, guess what? Same one. I just did a homework problem for you. Well, you did it, but we did it together. So, there's homework 1.7, number 6. You have it already, so pretty good. All right, let's do number 5. Y'all are doing awesome. Thanks for staying with me. I know, it's a Tuesday. A motorboat heads upstream at a distance of 24 miles. Okay, that's good. On the Illinois River, and the trip takes 7 hours. That's all right. The trip back takes 6 hours. Yeah. Assuming that the motorboat maintained a constant speed relative to the water, what was its speed and what is the speed of the current? What would X be? That's the first thing they asked me for. It says its speed. What speed? Boat speed. Boat's speed. And then what's our second variable? The current speed. Good. If we have a distance, we're going to be using distance equals rate times time here. What's my distance? 24 miles. So 24 is equal to. Now I need my rate. The motorboat is going upstream to begin with. So I'm going to take my boat's speed and my current's speed and do what between them if I'm going upstream? Subtract, because the current would be dragging the boat's speed slower. So you're going to subtract, and then that's multiplied by the time it took, which is 7 for upstream. So your first equation is your upstream equation. Your second equation is going to be downstream. With downstream, the boat speed and the current speed is working together. So we're going to have 24 because the distance doesn't change. And if they're working together, it'll be x plus y times what? 6. We need these equations in standard form before we even do a matrix. So let's get these in standard form first. I'm going to distribute the 7 backwards. And so my first equation is going to be, I'm going to turn it around. We're going to do 7x minus 7y is equal to 24. Because remember, an augmented matrix has the total on the right side. What's the second equation going to say? 6x plus 6y, good, equals 24. Those are the equations we're going to use for our augmented matrix. Rizo, will you tell me the first row in our augmented matrix? Perfect. And Demi, tell me the second row. Perfect. And let's see. Emma, what are we doing with that matrix? Row ref, RREF, reduced row echelon form, and then we're going to get an answer or solution matrix. Go ahead and try it on your own, see if we can get the solution. It will be weird. Why did I say it was weird? You got decimals. The first part should be 1001, dot, 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 dot. Do we have to write all the decimal places down? No, how many? 3 after the decimal place. So tell me what the first number is. 3.714. Tell me what the second decimal is, and be careful. Are you sure? 6. It rounds up to 6. Hey, Hillel, can you tell me a conclusion statement? Okay, boat goes 3.714. We're going to stop it at miles per hour. And then next one. $0.286 what? For what? Nope. The current. So current goes 0.286 miles per hour. That's the same upstream and downstream. The difference is upstream, they work against each other. Downstream, they work together. Okay? Questions on that one? Let's keep going. I figured that's what that was. We're not going to do 6. That's going to be tomorrow. We're going to do 7. Hey, we're almost done. You guys are being awesome. Thanks. Did I just say 6, 7 again? I'm so sorry. A 15% vinegar solution and a 30% vinegar solution is mixed to make a 3,000 milliliter solution that is 18% vinegar. How many milliliters of each of the 15% and the 30% solutions should be used? This is number 7. Your question is asking you how many milliliters of each solution should be used. Those are your 2 variables. So X is milliliter amount of 15% solution. Y is milliliter amount is AMT of 30% solution. You should have 2 equations here. One equation representing the percentage of vinegar in your solutions. The other equation is how many milliliters are in each solution. So let's start with the milliliters in each solution. X is the milliliters in the 15% solution, so X. Plus Y is the milliliters in the 30% solution, so Y. What is that equal to? 3,000. That's your total amount of milliliter solution. So this equation represents the milliliter amount. And then you're going to have another equation representing the percent of vinegar in your solutions. How much of the first solution is vinegar? 15%. How do you write 15%? 0.15. So 0.15x plus, I'm combining that with my 30% solution, which is y, and I need to multiply that by 30% or 0.30y. This is where it gets weird. I have 15% and 30% going in to make what? 18% of how much? 3,000. So you've got 18% times that 3,000. Now when I have 18% times 3,000, I'm going to teach you a little trick here. And be careful with it. Watch this. Don't do just yet. But if I were to put my matrix in for this, second matrix, just watch, don't do yet. 2, 3, 1, 1, 3,000. Is that right? And then 0.15, 0.30, and then notice what I'm doing. Do you see what I'm doing? I didn't calculate 18% of 3,000 yet. When I press enter, it will do that for me. So if you want to wait to do it until you put in your matrix, you can. Regardless, you need to write that number down. The way I'll write that number down, usually I'll draw like an arrow through this, and I'll say this is 540. 2 by 3. You got 2 equations, 3 spots. Your matrix should be 1, 1, dot, dot, 3,000. Be careful with the zeros. 0.15, 0.3, dot, dot, 540. We are RREFing that. Try that, see how it goes. Let's see if we can get our solution. Jackson's paper, 1, 0, dot, dot. Tell me if you got something different. 2,400, 0, 1, 600. Yes? 2,400 what? Milliliters of 15% solution. 600 milliliters of what? 30% solution. Anybody get anything different? Are we okay? Flag me down if you're not. Is this getting like super easy? Good. Let's do number 9 and then we'll be done. I'm sorry. Just number 9. You'll want to do number 9 with me, trust me. Hey, why do you think I'm picking the examples I'm picking? So I'm doing 9 of these. You have 5 of them. Why did I pick I'm doing 6 of them. You have 5 of them tomorrow. Why would I pick the 6 that I picked? They're harder. I always teach the harder ones. And they're a lot like the 5 that you're going to have to do. So I picked 6 examples that would be good examples for us to do together so that tomorrow you'll be okay doing the 5 I'm asking you to do on your own. So let's do number 9. Why am I going to do number 9? We'll find out. Don't worry. Marina had $24,500 to invest. She divided the money into 3 different accounts. Do we see why I'm doing number 9? At the end of 1 year, she had made $1,300 in interest. The annual yield on each of the 3 accounts was 4%, 5.5%, and 6%. If the amount of money in the 4% account was 4 times the amount of money in the 5.5% account, how much had she placed in each account? So in each account, the first account will make X equals dollar amount, let's say at 4%. That's the first account. Y would be the dollar amount at what percent? 5.5%. And then the last variable, Z, is going to be the dollar amount at 6%. Do we know how much is in each account? No, but all of these will add up to be what number? 24,500. So X plus Y plus Z is going to be 24,500. That represents dollar amount. Now let's talk about another equation that would represent our interest. How would you find the interest you've earned in the first account? What's the first account's rate? 4%. How do you write 4% as a decimal? 0.04, and that's multiplied by the amount in account 1, which is X. Same thing's going to happen with Y, but this one's going to be 0.055Y. Remember, you move the decimal place twice to the left. Plus, what's the decimal in front of Z? 0.06Z. That's the interest in the first account, the second account, and the third account. How much should that add up to be? 1,300. That's how much interest she earned. Now we just have to write one more equation because we have 3 variables. If you have 3 variables, to be able to solve that, you need 3 equations. The next to last sentence says, oh no, it's the last sentence, the money in the 4% account. What is that represented by? X is equals 4 times the amount of money in the 5.5% account. What is that going to look like? 4Y. And what's the issue there? There's no Z and? There's only 2 variables. What else? Before I even start my matrix? It's not in standard form. How do I get it in standard form? Subtract the 4Y. So X minus 4Y is equal to what? 0. Now we can write our augmented matrix. What are my dimensions? 3 by 4. I think I called on everyone today, right? Okay. 1, 1, 1, dot, dot, 24, 5, 0, 0. You don't put commas in your calculator. Second row, 0.04, 0.055, 0.06, ... 1,300. Somebody in B block put 13,000 there. Be careful. Don't put 13,000. It'll mess it all up. And the last one, 1x minus 4y, 0 z's equals 0. What are we doing with that? RREF equals. Solution matrix should start with this. And then we will see what we get as a solution. Go ahead and try it. We'll see what we get. Your last column, you should have 8,000, 2,000, 14,500. I'm okay if your conclusion statement says $8,000 at 4%, $2,000 at 5.5%, and then $14,500 at 6%. That is the end of the examples I have to do with you today. You've got about 8 minutes left in class. Try to stay on top of your homework this week. You do have a unit test on Friday. Tomorrow you'll be doing the 5 questions we didn't do, but it's going to be in like a different way, so you won't be... I wouldn't do them ahead of time. I wouldn't worry about them ahead of time. And then after we do those 5 examples, you'll have your word problem quiz, and then we'll do more word problem practice. Let me know if you have any questions or if you need any help.